Hello friends, welcome to my YouTube channel, and today we are going to discuss these topics. And one of my subscriber requested to make a lecture on these topics: transpose of matrix, symmetric matrix, symmetric matrix, and adjoint and inverse matrix. Okay, so before we start, please subscribe the channel, hit the thumbs up button, also share with your friends. Inspire me to create new contents for you. And if you want to follow me on Insta, this is my Insta ID: Oza Lukhajit, OJHA Lukhajit, LAKHYAJIT, Oza Lukhajit 123. This is my Insta ID. You can follow me on Insta. Okay. So now let's start. So first, let us discuss about transpose matrix. Okay. So now you see, suppose we have a matrix. Okay. Let us suppose we have a matrix A. Let me write here the transpose matrix of a given matrix suppose A can be obtained by interchanging the rows and columns, interchanging the or you can say interchanging the rows and columns of the matrix, right? For example, suppose we have a matrix A is given by 1 4 2 5 3 6. So let's make this column as row 1 2 3, then next column second row. So second column is made second row 4 5 6. That's how we can interchange the rows and columns. Then this is transpose matrix of A. This is transpose matrix of A, right? So that's how. Let us discuss about symmetric and symmetric matrix. Okay, so when a matrix is said to be symmetric, let me tell you now you see a square matrix suppose A. Square matrix means a matrix of order m into n or n into n. That means number of rows must be equal to number of columns. Okay, then it is said to be a square matrix. A square matrix is said to be symmetric if it is equal to its transpose matrix. That is, A is equal to transpose of A. Transpose of A also written as A dash. Okay, also written as A dash. Right. Now, for example, suppose we have a matrix A is equal to, suppose, 1 2 3, then here we have 2 3, right? Then 4 5 then here we have 4 5. Okay, then you see at 6 suppose. Okay, now you see, if you find a transpose of this, right, if you find a transpose of this, if you interchange the rows and columns, first make this rows, let me write this first row as column, then we're gonna get 1 2 3, then next row as a column, then we're gonna get 2 4 5, then third row as column, then we're gonna get 3 5 6. So here you see both A and A transpose are equal. So that is an example of symmetric matrix, right? Now skew symmetric matrix. So let me write here, let me take another slide, new slide. Okay, so what do you mean by skew symmetric matrix? Skew symmetric. Now you see a matrix, a square matrix. Okay, a square matrix A is said to be skew symmetric if its transpose matrix is equal to negative of this matrix, right? For example, let me take a matrix, suppose A. This is a matrix which is, suppose, let me write 0 1 minus 2, then let me write here minus 3 0, then 5 suppose. Just wait, let me make it 3. Okay, let me make it 3. Then here we have, suppose, 2 and minus 5, and let me take here 0. Okay, so now you see negative of A, that means you need to multiply minus 1 with this A matrix. Then if you do so, then what you're gonna get, then you have to change the sign of sign before each element. Negative of 0 is simply negative, then minus 3 plus 2, right? Then plus 3 minus 0 is 0, minus 5, then minus 2 plus 5 means 5 simply, right? Then 0. Okay, now you see, let's find the transpose of this matrix. Okay, what will be the transpose of this matrix? Transpose of this matrix, first make it a column, 0 3 minus 2, then make this row as column, write this second row as column, then minus 3 is 0, then 5, then third row as column, 2 minus 5 0. Now you see, if you see this one and this one, both are equal, right? So here we are getting A transpose is equal to minus A. So that's why this matrix, this given matrix A is skew symmetric matrix, right? So hope you have understood this. Now let us discuss about adjoint of a adjoint matrix. Now you see, if a square matrix, suppose A is a square matrix, right, as a square matrix, then adjoint of A, then adjoint of matrix A, which is represented by ad A, okay, is the transpose of the matrix formed by the cofactors of the elements of the determinant A, right? So let me show you how. Let us take an example. This is the given matrix A, suppose 6 4 3 4 3 4, then 3 2 2. In order to find the adjoint matrix, first let me write the determinant of this matrix is again 6 4 3, here 4 3 4, then 3 2 2. If you evaluate it, then what you're gonna get, first you have to write 6, then let me write here 6 into, now 3 2 is 6 minus 2 4 is 8, right? Then multiply these two, then subtract product of these two, right? Hope you have understood this. So now then what we're gonna get here, 3 into 2, that's gonna be 6, minus then 2 4 is 8, right? Then put negative, then take this term 4, right? Then if you take this term, then ignore this and this column, right? So then you have to multiply these two, then subtract the product of these two. Okay, 4 to the 8, 3 4 the 12, 8 minus 12, then again positive, then take this term now, right? Then ignore this first row and last column where it lies. Okay, so then 3 sorry, not this one, 4 to the 8, then 3 3 is 9. Okay, 8 minus 9, 8 minus 9, right? So let's evaluate this. 6 into minus 2, then minus 4 into minus 4, then plus 8 minus 9, that's going to be minus 1, right? Then what we're going to get, minus 12 plus 16, then minus 1, and here you see, actually here I have to put 3 here, I forgot to put that. 3 into minus 1, that should be minus 3, right? Minus 3, just wait, 3 into minus 1, right? So now that's going to be equal to 1, right? So now let us find the matrix of the elements of determinant A. Is that matrix will be given by, let me show you how to find that. First, you see, just wait, let me write this clearly. Okay, it's very simple. Okay, first let us find the cofactor of this 6, this first element 6. In order to find the cofactor of this, ignore the row where it lies and ignore the column where it lies. That means first row, first column should be ignored. Then multiply this one, then subtract the product of these two, 4 and 2, right? First take 3 and 2, that's going to be 6, right? That's going to be 6. Then that's going to first put positive, then that's going to be 6, 3 into 2, then 4 into 2, minus 4 into 2, that's going to be minus 8, right? Then again negative, alternatively positive negative, right? So now take this 4, then again ignore second column and first row, right? Then you need to multiply 4 into 2, that's going to be 8, then minus 3 into 4, that's going to be 12, right? That's going to be 12, right? Let me write it clearly, that's going to be 12. Then again positive, okay, then again positive, here you see, just wait. Okay, so now cofactor of this, then take 4 2 8, then 3 3 9, 8 minus 9, 8 minus 9. Then as you have put here positive, it is not necessary to be written this positive sign, just consider this is this one as positive, right? But when in case of negative, you must put the negative sign, right? So now it should be alternatively positive, negative, then positive. Then in the next row, this should be negative, positive, again negative, so on, right? So here in the first term, we're going to put negative in this case. Now let us find the cofactor of this 4, then ignore the second row and first column. Then if you do so, then ignoring the second row and first column, just multiply 2 and 4, that's going to be 8, then 3 and 2, that's going to be 6, 8 minus 6, right? So then positive, that's going to be 8 minus 6, right? Then now negative, find a cofactor of this one, right? Sorry, this was the cofactor of 4, right? First one, sorry, 8 minus 6, that should be the cofactor of this, right? If you ignore this one and this one, then 4 to the 8, this is 8, then 3 to the 6, this is 6, right? So hope you have understood this. So now you see, let's find a cofactor of 3 now, 3. So now ignore this and this, then 6 to the 12, then 3 to the 9, then 12 minus 9, here it should be 12 minus 9. Then cofactor of this 4, then ignore this row and this column, right? Then 6 to the 12, 3 4 the also 12, 12 minus 12, so that's going to be 12 minus 12, right? So 12 minus 12, right? Now as we have taken negative sign here, now take positive, okay? Then take positive, then take the coefficient of this, ignore this row and this column, then 4 4 the 16, 3 3 the 9, so 16 minus 9, so 16 minus 9, let me write here, 16 minus 9. Then again negative, right? Here it is positive, so now next should be negative. So now cofactor of this 2, so ignore this and this, then 6 4 the 24, 3 4 the 12, okay? So 24 minus 12, 24 minus 12, right? 24 minus 12. Now take the cofactor of this, then positive again. To find the cofactor of this, ignore this column and this row, then 6 3 is 18, 4 4 is 16, 18 minus 16, right? 18 minus 16. So that's going to be equal to, let's evaluate now, 6 minus 8, that's going to be minus 2, then here it is minus 4, then minus minus plus, right? That's going to be plus 4, then here we're going to get minus 1, so minus minus plus 2, sorry, that should be minus actually, here plus 2, then minus, right? Then similarly here it should be 3, and it negative 0, positive 0, same thing, doesn't matter, right? Then 7 here, then minus 12, then 2. So that's what we have got. Now let me copy this and let me go to the next slide, okay? Let me copy this matrix of the cofactor of the element of the determinant A. So this is the matrix of the cofactors of the element determinant A, elements of the determinant A. So if you take the transpose of this, then you're gonna get the adjoint matrix of A. Adjoint of A is equal to transpose of this one. Take the transpose. Take the transpose. So what to do? Interchange the rows and columns. Interchange the rows and columns. Right. So then what you're gonna get? Write this row as a column. Minus 2, 4, minus 1. Then write this row as column. Minus 2, then 3, then 0. Okay, and then this row as column 7 minus 12 then 2. That's what we have got. So this is the adjoint matrix of A. Now suppose if you need to evaluate the inverse of this matrix A matrix, inverse of A, right? So inverse of A, let me go back to the previous slide. So inverse of A, which is denoted as A inverse, is equal to, that is given by adjoint of A divided by determinant of A, right? So therefore the inverse matrix, just wait, so A inverse, inverse matrix of A, therefore inverse of A is given by adjoint of A divided by determinant of A. So here the adjoint of A is this one, and determinant of A we have got 1, right? If you if you divide this, or you can write this one this way, 1 by determinant of A into adjoint of A vector. So that means you can write 1 by 1, then this not A vector, adjoint of A. If you take the adjoint of A, that is minus 2, 7, right, 7, then 4, 3, minus 12, then minus 1, 0, 2. This was the adjoint of A, right? So adjoint of A, and here we have 1 by 1. This one is nothing but determinant of A, right? So if you multiply this one with each term, they're going to remain same, right? If you have 2 here, then you have to divide each term by 2, right? So that's why it's gonna be equal to this. Okay, after dividing this one by 1, we're gonna get the same thing, right? That means we have to divide this adjoint by its determinant, right? Okay, if you get the determinant is equal to 2 or 3 or something else, then you have to divide each term by that number. Okay, so now we are getting determinant is equal to 1, so that's why this matrix remains same, right? So hope you have understood this, how to find the inverse and adjoint matrix, transpose matrix, right? So thank you for watching. See you in the next video.